Okay, so what's missing here is we got to pass in the amount. So it's an actual argument to our. I feel like I can just do amount. This is the transfer. Yeah. So what does it take? It takes all this account, takes a context, a CpiContext, which it itself has all kinds of stuff. And it takes an amount, which is it, because we pass it as part of the instruction data. And then we have this, which this is a result. So we have to use this used in question mark to decide whether the operator should produce a value. Yeah, this is a control flow kind of thing. So like when you're dealing with like a result, it's going to either be an okay, it's going to have like an okay result or an error. Those are the only two deals, and this is a handy little check with the question mark. So it's kind of don't take Rust instructions from me. Now it is complaining on a couple of things. One thing I know for sure about, like, what is this about? Mismatched types. Expected a borrowed uint, and instead we got a borrowed anchor account info. Well, that doesn't. Hang on. Signer seeds. Signer seeds is actually not the full-on account. It's actually the ledger.authority. Is that better? Yeah. Okay. That was a mistake. Because these are all the seeds. Center seeds for ledger PD. Yeah. So at this point, I could save this, build, and test it out almost without bothering with the credit variant. And I may do that. Baby steps. Yeah, there is no. We didn't pass in. Yeah. And that basically means I didn't pass in an ATA for the connected wallet. So didn't think about that. So here, this create entry, this is kind of like the validation struct that Anchor uses, like for context, right? And inside, we pass all the input accounts, all the accounts that we're going to need to execute this. I'm missing the wallet associated token account. Yeah. So what this looks like is just like let me see, something that's kind of cool to look at. It's like, here's just like a random soul scan. Here's a transaction. So you get this transaction signature and you can like see kind of all the stuff that happened. Well, here are the instruction details. So I'll zoom in a little bit. You have, here are the details of this transaction. It's this right here, input accounts. It takes all the accounts that are needed for this create associated account instruction. So it needs these 4, and then it goes and does the whole instructions. So it's these input accounts, what corresponds to what we're doing here inside of this validation struct. So that's the connection. That's how it's related. So yeah, start to fill in some of the, connect some of the dots. So we need the entry, we initialize the entry, we grab the ledger, we grab the token account, we grab the authority, a mutable authority, and I'm wondering, I think that's how we do it. So let me see. I'm trying to think, like, how did I do it here in the escrow? Yeah, I passed in seller out token account, which is basically the wallet token account. And yep, this is something that I'll do. Now, I will have to do some sort of constraints to double check that this ATA, this authority token account, is associated with the same mint. So let's see what we can do. We need, it's another account, and we're going to need a mutable because we're going to be potentially well, no, we are going to be for sure, like, depending on the entry, we're either going to be transferring to or from this account some SPL tokens. So it needs to be immutable. We can public, I'm going to call it authority token account. We're going to take advantage of these constraints. So we're going to say the authority, let's see, authority token account dot mint is equal to the token account dot mint. Oh wait, token account dot mint dot key, right? Because the token account, we set the authority to the ledger and we set the mint property, so those two should be the same, I feel. Another constraint possibly could be the authority token account dot owner should equal our authority account dot key, right? Because like here, like, gotta make sure that this, we grab the right one. I feel that could do it. Yeah. So then if this is the instruction, another account added, then it makes it available here in our context. Yeah. Mutable borrow occurs here. Cannot borrow. So do I need like a reference? Hang on, let me just see. Let me get what I think I need. Authority token account info. Getting access to the token account. It needs, cannot borrow. Maybe I don't need to borrow it again. Maybe because I've already, it's the ledger and I already accessed it at 34. I see, line 34. It's saying I already have it. So, yeah, ledger. And I guess could do account info. Would that work? Yeah, I already had access to it because I grabbed it out of here. Okay. Same thing here. I already had ledger. So let's just do, it's going to be a ledger. Oops. Oh, come on. Ledger name. And we've already borrowed it. So I'm gonna do that. I've already got a mutable borrow on this ledger from line 40. If I hadn't kind of like destructured it or extracted this ledger, well, then none of that would have have worked anyway, because I still need to do, but that's basically why it was complaining at me. Yeah, so here we have, I feel like this is it. I feel like this is kind of our instruction that we would need for debit. So next, before I do anything for the credit, I'm going to just test out this debit to make sure it can work. Which means I need to, like, from the test, I need to mint some supply to the wallet that I'm using for testing. And I also need, but in order to do that, I need to first create the associated token account, which it kind of does it all using some of these. So that's what we're going to do. And then I'm going to try to see if we can debit and perform. Oh, hang on. I'm thinking about this. I'd have to, like, in the test, first credit the ledger token account to give it some supply. So then it has some tokens to send back. Shit. Probably should have worked on credit first and then the debit. So, all right. Well, all right. Let's just do the credit then. Okay, so one thing for moving on, finally got my chai assertion library for testing. I was trying to get that loaded early, but one thing that I want to show that also that things are working correctly in our test is this particular entry. And I can actually get rid of this now, so this particular entry, we use the entry type of credit. Okay, it's one of our entry type enums that we defined in the program. In my entry state. Okay, but what I want to show is that on 35, this part right here, we currently inside of our instruction, we're doing a match on this enum, and I'm only basically matching on the two variants. So there's only two options here, and if it hits debit, it prints, debit or credit. Yeah. Well, the test, this first test, this create entry one inside ledger one, blah 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 blah, I used credit. Yeah. And down below, I was trying to make, come up with some creative way. I need to, to kind of verify that it worked, but because I did that message macro to log inside of the instruction, I'm going to show a cool thing by why Solana logs. So right now I'm running the command Solana logs, and it just, all the transactions and whatnot. So check this out. If I go here is my program log, create ledger. Yeah. And it goes through and it does all the stuff that we told it to do. And then create entry. Now check this out. Right here, program log credit. This is a program log. This is coming from my instruction. So this is from my program, and that last little create entry, when it invoked create entry, it goes through and does all this stuff, and then it logs some stuff. And one of the things that I tell it to do is to print out the type. So if I basically, if I went back and I said, you know, if I wanted to do like entry type, you know, something like that, entry type, and change it, rebuilt, redeployed, and then retested, this log would get updated. This Solana log right here would show my new text, essentially. So yeah, that's how this stuff is kind of tied together. Now, and I may actually get to show that here. So this question on how to check enum structure. Don't have that yet, but create token account balance dot value dot amount. Which is a string to equal because it's 0. There's no we haven't done anything with it. Okay, but this should be a type string. It's the raw amount. There is the there's a couple other properties: amount, decimals of the mint, UI amount, and UI amount string. That is the UI amounts where you get it's easier for the user. Like we'll see like 3.2 tokens instead of like 3,200,000,000 tokens or something like that. So but for now I'm just going to use amount, and that should do that. Now, how do I check enum structure? Well, before I move on to actually making this a little bit more you know, doing the SPL transfers in the program, I saw this in Chai. They have this like expect something to have property. Now, it's not quite the same, but I could maybe say expect current entry dot entry type dot to have own property. Ooh, these are neat. Have own property. Language change. I'm not. Let's just follow this basic example. To have property. And I can put it in something like that. Don't know. Certainly don't know if that's the correct way. Like here, the docs is showing like expect something to have property, and then the property name in quotes, and then dot with, I have a weird, when we're doing this for enums, the structure is different. It's like this. So this entry type is an object, and it should, have property credit. And I'm not going to say like is equal to anything. I'm just going to see if it can check that it has the property. And I'm assuming this returns a like it's just like perhaps it's a Boolean. It's a chai.property. So it's an assertion. It returns an assertion. So I don't know. Let's see if this does anything. So back to here. This is not like totally necessary, to be honest. Anchor build program ledger and then deploy it. So because I modified that message macro, nothing else, but technically our program did change a little bit. Now that that's done, get my logs going on again. Okay, and then we can do the test again and get lucky, see if it works. Yeah, cool, back to back. So that's cool, which means that this whole has property value could be a good way to use, you know, just to kind of check and make sure that you know, when I'm dealing with like objects. And then last but not least, we have program log entry type credit. So this is my new message macro log. So we're looking good, looking real good. Now time for the fun part. So back in my create entry instruction, we gotta get we gotta do the hard stuff. This will be a little bit of a slog, but basically this is the to-do. We need to, I'm just thinking out loud here. Like update our token account balance to perform. So I'm thinking, you know, oh man, what are we gonna do? We're gonna, for like a debit, well, first things first, like where are these tokens coming from? Like in my test, I'm minting supply to the wallet at the top, right? We have the authority. We will use more wallets eventually. But I'm doing an airdrop of Sol, make sure that the wallet is funded to pay for the transactions. We mint a new token, and then when we create the ledger, we actually haven't done anything with the token. So we haven't actually minted anything to the wallet. So the wallet doesn't have any supply. All right, well, let's think about that. We need to do a mint too. So one possibility would be like, how are we going to give tokens to the users? So like they'll log in and they'll create a ledger. At some point in there, I need to have like a button that allows them to essentially like airdrop themselves some supply. gotta think through the details. So I'll figure out the supply in a little bit during the testing, because like what I'm thinking is like inside my instruction, I'm not doing any like, you know, use SPL from I mean, that's basically what we're going to do. So I will, on the front end, I will come up with a way here in the test. I will probably, for now, just generically, like one question is, I need to handle that. That's a to-do. But it could be just a simple, there is a, what is it? It's like a wait. This is where the, oops, didn't mean to click on that. Interacting with tokens. It's been a little slow. Here's the token program anyway. Here's another way. But like, keybear, creating your own. Mint. Let's mint some. First create an account to hold a balance. So we're gonna have to do some of this like mint, get or create. Mint2 is a helper. We like the token supply. Yeah, so we're gonna have to do this using the SPL token program from Web3. Mint to check, like there's, yeah, so we'll do that eventually when we get to it. So, but here, we'll assume that the authority has like enough. So we basically want to, in this case, we're going to debit or decrease the balance. So it's basically like access the token account and perform a transfer or burn. Maybe just a transfer to authority, something like that. And then the credit is a transfer the other way. So I've done this with escrow. So under the accept, so escrow lib. Yeah, so here we're going to do some of these transfers. Okay. And we're going to use anchor SPL token. Make sure we have that. I even have mint. I may need mint for we'll see. And then when I initialize the escrow, we are making a transfer into the token account. Yeah. So transfer seller's out token account to program owned escrow token. So here in our context, we have access to authority. Yeah. So this should be something like well, let's just start writing it. Anchor underscore SPL token, because we're using the token program to perform a transfer. Lowercase. Okay. When you perform these sorts of things, you need the first argument is a context, and yeah, one of the things that is one of the things that's happening when we initialize our ledger, when I create ledger, we set the ledger's token account, we set the authority to, let me show you. Well, let's keep on this page. Let's go over here. I'll do create ledger. Let's look at this. So part of my instruction is I'm setting right here 37. So when we init, when we create the token account inside of this ledger, we're setting the mint property on this token account to equal our token mint, the one that we're working with, and we set the authority to actually be the PDA itself, the ledger PDA. So, but we're making the PDA account the authority. So a PDA is kind of the authority to allow this transfer to take place. And so the way that you verify or allow something like that to happen is you have to sign this transfer using the PDA. But a PDA doesn't have private keys. It doesn't have a secret key because it's a PDA. It has a public key, but that's all it has. And so in order to do that, you have to do this kind of signer with seeds. And I do that right here in the accept. So in this case, it's going to look something like this, where all the instruction input accounts have been validated and verified by Anchor in our create, entry context. So far that's looking good because our tests are passing. We're not getting any errors when we pass some accounts. But the flow is this: we're going to transfer tokens from the ledger token account to the authority, to the wallet. And then we're going to transfer the, like that's essentially, and then on the other flip side of it, we'll transfer from the wallet authority wallet to the token account. So I'm going to follow this a bit. So I'm going to use transfer, and then we need a context, a CPI context. And it's not with signer, oh, maybe they changed it. I know that they are thinking about doing, it's not just like new, which is like a standard CPI, but like new with signer. Yeah, so look, it shows, oops, this said program. So this new assigner, it needs the program, the accounts involved, and the signer seeds, which in this case is actually our ledger PDA seeds, is my recollection on how this would work, because the ledger, again, is the owner or the authority of the ledger token account. So let's try this. I'm going to just so the program, well, what program are we using for this transfer that executes this? This is the token program, and we pass that into our context. So we can do our context accounts, the token program, and we need a account info. So like all of this that we pass inside of, like, we need the actual to account info. Okay, so every account that we're passing in here, we need like its raw like account info in order to perform this transfer. Okay, so that is the first thing. Remember, it takes a program. So this is the program. Then it takes accounts array, all the input accounts. Okay, so here we do anchor here we build up an actual transfer instruction where it, just like any other program instruction, takes an anchor, at least, takes the context and then any sort of instruction arguments. Okay, it's not like that per se. It's actually anchor SPL token transfer. Yeah, I messed up on that. Sorry. And here it needs the accounts in order to execute. So which accounts do we're building up this kind of instruction. So transfers do a from property, so a from account. Well, this is coming again. What did I say? It's coming from the context.accounts.ledger. No, yeah. Well, hang on. Token account. I don't think I could do ledger because that's a PDA. Token account to don't think that would work. Perhaps I could. That's I can investigate that later, but this is create. This is that. I mean, it has that, but I'm already passing in the in the context. I'm already passing in the token account. So I think I don't. Yeah, and you can see this to account info returns account info, and this is needed. So that's the from, and then the to. Well, where is this transfer going to go? So we're crediting back to the account, and it should go to the authority. But this is something I don't have. It's not going to go to. And it doesn't actually go to the authority wallet. It goes to the associated token account inside the wallet. That's it really needs to be like I don't think I can do don't think that's gonna work. Because that doesn't work. That's not going to that's going to be a this is like a right. I'm pretty darn sure I can't do that because that doesn't work like that. It needs the ATA. I know. Yeah, I know. So that's a to-do. So that means I need to. There's something. This is something I'm gonna have to do right here. We're gonna have to pass in. It's gonna be another account that we're gonna have to pass in to this in order to execute this. So that's see, I mean, it's an evolving iterative process, but let's say we had it. It would be like it would be accounts authority token account to account info, and this is going to complain because we don't have it. And then last, when we're building our transfer instruction, we need, there's a property called a authority, and that one accounts dot authority, and well, actually no, it's the authority of this token account, which is actually the ledger. To account info. Yeah. Now, again, we're still working within it takes a program, check. Next, it needs accounts. And then the last thing it needs is signer seeds. And it's got this weird, like, mutable, or not mutable, but like borrowed reference to like this nested uint 8 array type of thing. So, but I'm gonna have some comments here. So like, and there's a GitHub. There's a GitHub deal that they have open that they may eventually change with signer to CpiContext with PDA signature or something. So they may eventually change that, just as a little FYI. I came across earlier. So yeah, all right, so we're not done with our argument. So we've done the transfer, but what comes next is the well, let's think. What are the seeds of our ledger? Well, we have the prefix. We have the authority, wallet. And we have the name on the ledger. I may eventually come up with like some better seed because name, but it won't work because like I may need to make sure on the front end, but even if they try to like execute and my front end was crappy and they were able to create try to create a ledger using the same name, it will error on the program side on chain because that PDA will already exist because it's derived from the program ID, which is this whole ledger program, and plus all the other things that I tell it to. So it's very secure in that way, which is great, even if my front end sucks, which very well could be the case. But like, okay, we have, let's see, we got to borrow, and then, yeah, let's try this again formatting wise. It's a little wonky to follow. So there's array, another array, and then inside the seeds. Oh, and you also need the bump. So we get the, we're going to get from ledger, seed, prefix, as bytes. Okay. We need the authority. So CTX counts authority. We need the name. We have access to the ledger. So I could do, wait. Name. It's just a string, so I think I can just do as ref. And that should, oh, and last but not least, the bump, which itself is CTX, oops, sorry, I gotta take a break for a second. Just let me finish this part and then to be continued. Well, we stored it. And this is why it's kind of a good convention to store your bump. When you're creating a PDA, go ahead and store the bump to the account so you have it, bump. And it should be something like that. Okay. And then last, what are we missing? We've done the seeds, the transfer. It takes the CPI, and then we need to pass in the amount. So when this is the amount, and yeah, so almost done. So I'm gonna pause and come back to this.